So, hi Amy, how are you doing?
Hi, sir. I'm good, thank you. How are you?
Very good, very good. So, how's your preparation going for the competitive exam, which is soon going to come, just within 2 days?
Yeah, I mean, it's okay. I'm not feeling like that much confidence because obviously this exam it's for like year 13s and that, and there's only like two or three year 12s doing this because we had a choice and I said yes. So yeah, I'm gonna, like you said before, I'm just gonna take this as like a practice trial run and get ready for year 13 because then I'll
Perfect.
obviously have more time to prepare for it.
Right. Right.
So yeah, I'm just hoping on everything that you've taught me, just remembering those facts in my head when I go to the exam. So yeah.
Good. I actually analyzed last 7 years of your test papers of this math contest. And as we
Mm-hmm.
discussed earlier, we have already covered two major topics. One is algebra, the other one is functions, right?
Mm-hmm.
And we have seen how to solve multiple test questions using some techniques. So today I'll discuss another topic, which is trigonometry. So what I find here in this trigonometry related questions, geometry is a huge part. I hope you remember the
Okay.
circle theorem, which you did in GCSE.
GCSE
So
content.
yeah, 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 yeah. You may have to review
I
that
do
circle
remember.
theorem. Yeah, review that part, circle theorem. And yes, you're right.
Mhm.
There will be some topics which will be taught to you next year in year 13. And so you do have a disadvantage. However, uh, making an attempt to do this is a brilliant idea. It actually puts you ahead of others, yeah, I mean, who are in your own batch, right? Your peers. So that is a huge
I
advantage.
guess. Yeah.
Right. So let's see how it goes. But here are a few questions which we can practice and understand if similar kind come in the test paper, how you will be attempting that. So let me share the screen with you. So, these are based on geometry and trigonometry, right? So as I was saying, the reference is all UK Mathematics Trust Senior Mathematics Challenge test papers, past papers. So the material is developed for students taking senior mathematics challenge as you, Amy, after analysis
Mhm.
of past papers available on internet. So for some of them, last 5 years, they even provide solutions. And for the others, we have the questions. So you can go through them and practice also. Now, the questions which I have taken here are based on sine law, cosine law, and circle theorem. I find these to be very important topics from this competition point of view. Now, here are a few
Mhm.
formulas for your ready reference. Sine law, as you remember, sine A over A equals to sine B over B equals to sine C over C. And cosine law gives you side when you know all other sides and an included angle. So C could be written as A square plus B square minus 2AB cos C square root. So that is the kind of formula. Then there are some interesting formulas to find area of triangle from different conditions, right? So if you are given two
Mhm.
sides with included angle, I hope you remember, you can find the area, half AB sine C. So that is area
Yep.
of a triangle. In case we have two angles and an included side, even then we do have a formula which is given here for your reference, right? So there also
Oh.
we can find it. Yeah. So if you have two sides and an angle, we have half AB sine C. And if you have two angles in the side, we have another formula. As far as the area of triangle is concerned, which is a very important topic, we have already discussed Heron's formula, right? Where the three sides are given to
Mhm.
you, semi perimeter, and three sides give you the area.
Yep.
We also seen in coordinate geometry that area of triangle can be found by a formula which we have already shared with you. Correct?
Mhm.
So basically, these are the three type of questions which I'm going to take. We'll have a different kind of a polygon here, and how do we find area or a perimeter of a polygon? In this figure, one side is missing, so we may have to find that particular side to find the perimeter. And to find the area, we may have to divide it into a couple of triangles. Once we have few triangles, adding their area will give us the total area. So that becomes the
Mhm.
concept. Now, in the second question, we have given some angles and we need to relate them. So, relating these angles may require alternate segment theorem applications and some trigonometric identities. Here is another very interesting question where we have a circle within a semicircle, another semicircle, like a combination of a few circles, right? So you can
Yeah.
see combination of these two figures. We have circles and triangles combined. You get the idea. So when you have
Yeah.
circles and triangles combined in many different ways, how do we solve such questions? That is what we're going to look into.
Mhm.
So that will help you, rather give you a good foundation on attempting to solve a question which is based on circles and triangles and inscribed figures. Correct?
Right.
That's the whole idea.
Mhm.
So let's begin with the very basic concepts. I know it's been a long time since you took GCSE. So we'll go through the alternate segment theorem first. It says
Yeah.
the angle between the tangent and its chord is equal to the angle in the alternate segment. Statement seems to be very easy but very difficult to understand. So when we say angle between the tangent and the chord, so the chord here is AB. You see that? And the angle is the marked angle green. So that is the
Mhm.
tangent. Tangent always makes 90-degree with the radius. There is no radius in this particular case shown, but the chord
Right.
A and the angle in green is shown to us. So this angle is equal to the angle in the alternate segment. So how do we find this alternate segment? What I do normally is this angle is in this segment. Is that clear to you? It is here, correct? Alternate segment is right
Yeah.
across. So if you see right across, then you find that angle which has been marked as yellow. So this green and yellow
Oh,
angles are equal. So that is how you find the alternate segment. You get the idea. Okay?
yeah.
We will now see how to prove it. So here is a small proof for it. So what we have done is the construction is A to D is the diameter. So from A, there will be some center of the circle given to you. You can draw a line, get the diameter AD. So that means one half on which side we have B is a semicircle, correct? So if I join D with B, then I get a right triangle ADB, right? As shown here. And in this
Right. Yeah.
triangle, the angle at B will be 90 degrees because it is in semicircle, correct? So we do have a right angle triangle here. So this angle being 90 degrees. Now, if that is 90 degrees, we have to relate this angle with the outside angle. So what you also know is that since that is the diameter and the tangent will also make 90 degrees, correct? So,
Yeah.
so
Dimension tangent. Yeah.
will make 90 degrees, and therefore this angle will be how much? This angle will be 90 minus, let's call this angle as alpha, right? So this angle here will be 90
90
minus
minus
alpha, correct?
alpha.
If that is
Mhm.
90 minus alpha, then this is how much? This is alpha, correct? So the angle at D is same as the angle which the tangent
Angular.
makes with the chord, correct?
Right. Yeah.
Now the chord is common with C, right? So C and D should be equal, so C is also alpha. You get the idea, because
Hmm.
they are made by the same arc 8B, right? So that is a simple proof, and
Um,
this is how we should understand the alternate segment theorem. It's very simple to understand, but it has high utility. So you have understood the theorem, you can easily identify
yeah.
the two angles which are congruent, correct?
So they have to be from the same arc.
Yes, of course. So this is the same arc,
Okay.
and to identify the angle, like you can see this green and yellow angles are equal, and we have also shown you
Yeah.
proof, right? Very simple, straightforward proof, which we have gone through.
Mhm.
Is this absolutely clear, Amy?
Yes.
Okay. So now, here is the question. Can you please read this question?
Um, a circle touches the sides of triangle PQR at the points S, T, and U as shown. Also, PQR equals A, the angle PQR equals A, angle
Yeah.
PRQ equals, oh, alpha, beta,
Right.
and yeah, angle TSU equals gamma. Is
No,
that
correct.
physics?
Yes.
Which of the following gives gives
Gamma.
gamma in terms of alpha, beta?
Right. So basically, we need to write this angle gamma in terms of alpha and beta, right? And these are four different choices given to you. Now, I've
Right.
taken this question from UK Mathematics Trust Senior Mathematics Challenge 2015, long time back. Question number 12,
Mm.
right? So it's medium grade difficulty level. Okay. So this is the question which we need to solve. Now, here is a very simple proof. Since you know that alternate tangent, right? Alternate segment.
Mm.
Now, look here. We we can see from this particular diagram that okay, there can the circle touches the sides of the triangle PQR at S, T, and U. So the circle is touching these 2 points. Probably this point V is T, S, T, and U, right? So maybe yeah, at S, T, and U. Also, angle PQR, those are alpha Which of the following are correct? Now, you can see from here that if this is alpha and beta, then what is this angle? This angle here will be 180 minus alpha beta, correct?
Alpha
Bigger
and
triangle.
beta. Yeah.
So the outside angle we have gone to straight. Now here, PQ is tangent to the circle. So this PQ is tangent to the circle. The length of the tangents from the point is equal. So that is another theorem. If you have an external point, then the tangents will be of the same length, correct? From any external point,
Oh, okay.
length of the tangent is same. Now, if the length of the tangent is same, then you consider this particular triangle. Those two angles should be equal, correct? Because it's an isosceles triangle, correct?
Oh, yeah.
Right. So the triangle, I'm sometimes I write T and sometimes V. So I mixed up this T and V. So PUT is an isosceles triangle. So this triangle on the top is an isosceles triangle. So that really means that these two angles are equal, right? So how much are they equal to? 180 minus angle P, half of it, correct? Because now this small one is also 180 is the sum. Therefore, each angle here is equals to half of 180 minus angle P. But we know what angle P is. Angle P is 180 minus alpha plus beta, right? From the
Hmm.
bigger triangle, 180 minus alpha plus beta. So if you open this up, we get angle PVU as half of alpha plus beta, right? So we get angle PVU as alpha plus beta, correct? So this angle is known to us as half of alpha plus beta.
Yeah. All right. Okay. So diagram really helps. So do you recommend doing diagrams in the thing?
Diagram is given to you. This diagram is given to you.
Oh, okay. That's all
Right.
right then. That's helpful.
So now, if you look into this, let me just remove all of the things so that the angle which we are interested in figuring out is now absolutely clear. We know this particular angle here, which the tangent makes with the chord is half alpha plus beta, right?
Hmm.
If you apply this alternate segment theorem, this angle should be equal to gamma, correct? Because that is the angle which the
Yeah.
tangent is making with the chord, and that angle should be equal to gamma. So that is the value of gamma. Do you see that? Gamma is half of alpha plus beta, and so you get option A as the right option.
Yeah. That makes sense.
Makes sense, right? So we approach from point
Yeah.
P downwards and see the angle which the tangent makes with the chord, and then the alternate angle was the gamma, and see how beautifully it all comes together. It's a very difficult question
Right.
to realize, but if you combine this logic, then it becomes much simpler. Correct?
Hmm.
Okay.
Yeah.
Now let's look into some other questions which I have taken. And this is another very interesting one, slightly more complicated because we'll be applying many times sine law and cosine law to find the area and the perimeter. So I split this question into two parts. One is find the perimeter of the given figure. So here's the figure given to you. We are not given the side EF, ED. This side is to be known. So how do we find that side? So look into the triangle where at least three things are given to you. So triangle at the bottom, which you have to divide them into triangles to find the side or the
Yeah.
anything, right, to solve them. So what we do here is first we'll join A to C. So if I join A to C, I do make a triangle right there. Now this triangle, I will apply cosine law to get this length, correct? AC. So applying the cosine law, I find the length AC. So AC is 15 square plus 5 square minus 2 times 15 times 5 times cos of 35 degrees, which is the included angle. and using the calculator, we come to the value of 11.275. So we know this side is 11.275. Now we'll move further, join E to C. Okay, so this C should be capital. Now again, uh, but before that, this 70 was the total angle. In this triangle, let us also find the smaller angle. So smaller angle we can find using sine law. So I use sine law to find the angle CAB. So sine of angle
Right.
CAB over 5, applying this sine law, we got that to be equal to the value, which is angle is 55.3, right? So the ratio was that much. Sine inverse of this calculation, 55.3 degrees is what I get as that angle. So if I take away 55.3 degrees, then I get the, sorry, I got that angle is only 14 point. This was 14.73, which I rounded to 14.7. So this angle
Yeah.
here is smaller angle, which is 14.7. Once I take away 14.7 from 70, then I get the bigger angle, which is 55.3. So that means I can now solve the triangle AEC, right? This triangle I can solve. I know the included angle. I know these two sides. That side is 11.275. Again, applying the cosine law, we can find the length E to C. So E to C I found as 9.94. Once you get E to C as 9.94, then we have a right triangle to solve. And in this right triangle, we can use a square plus b square. Well, it is a hypotenuse known to us. So a longest side minus 6 square, the leg, square root gives us the length of the other side. Now, once we know all the sides, the perimeter is sum of sides, just add them up and you get your solution. Clear? So different times we have applied sine law and cosine law to get to the solution.
Yeah.
That is why
Like
I've
a
taken
combination of it.
combination of it. So it might
Mm.
take some time, but I think when they give you this kind of a question, they'll give you time for that also.
Would
Now,
they give this in my test?
yes.
No, because I don't have a calculator.
Oh, your test is
Oh.
without calculator? If it is without calculator,
Um,
if it is
yeah,
without
the senior
calculator,
math challenges.
okay.
Yeah.
In that case, you will be given the values which could be calculated without calculator. You get my point.
Okay.
Angle will be, for
Yeah.
example, 60 degrees. If I give you angle of 60 degrees, 45 degrees, for example, you get the idea.
Yeah.
Then it can work, right? So I actually
Okay.
picked up from one of my old examples and I just, but
Mhm.
it's important to understand the method, okay?
Yeah. Yeah. Yeah.
In the second question, I've all taken the values which we just calculated. Let us say these are the values which we just calculated. We need to find the area. Now, to find the area, important thing is remember this particular formula, which is half AB sine C.
Uh,
So if they give
mhm.
you a question based on this, angle C will be given to you as something like 30 degrees, 60 degrees, and 45 degrees. So you should know your special triangles, correct? Substitute the values,
Mhm.
and always they'll give you easy values to work with. Multiplying with some integers may not be a problem, right? So that should help you. However, the concept here once again is to split them into different angles at the area and to know when to apply which kind of formula. So in your question,
Yeah.
always there is a combination of formulas which are applied, not straight away.
Right.
That is what I'm going
Yeah.
emphasizing on. Okay, let's move on.
Mhm.
Take the next type of question, which is again a very difficult question. Can you please read this question?
The figure shows semicircles with center P and M, where M is the midpoint of AP. Points A, M, P, and B are collinear. A small circle of radius R is drawn with center 0,
Yeah, tangent to the
tangent
center.
tangent
Tangential.
to the semicircles.
Yes.
As shown. If the radius is if the radius of bigger semicircle is R, then find the expression for R over small r.
Correct. So many
Mm.
problems could be many. There could be a lot of sentences, worded problems. So it may be difficult to understand. So you have to break down your sentences and understand what they are really asking for. So let's go through this once again. A figure shows semicircle with center P. So the P center is right there, which is this one big semicircle, and M. So the second one center is M. So there you find that M actually is one of the side centers with that also P, right? So that is good to notice. So that is 1/4 of the whole length. Anyway, okay. M is the midpoint of AP, clearly written, right? A, M, and P are collinear. So these A, M, and P, these are collinear points. And B, this is a straight line. Okay.
Mhm.
A, a small circle of radius r is drawn with center O. So this is your small circle. Tangential means they will be touching. If the radius of bigger circle is r, capital R, then find the expression capital R over small r. So we have to find an expression for capital R over small r, where r is this radius from P to B. It is also equal to P to A. And since M is the midpoint, M to P is R by 2, correct? So this M to P will be R by 2, correct?
Yeah.
Now somehow we have to relate
Was it?
all these things, right? So we have to relate them all.
Mm.
How can you relate it? See, the good part is that if you look into the triangle, which is OMP, right? So OMP is the triangle in which we actually know all the three sides and the angle theta. All these answers are in terms of angle theta, right? Which is this angle right there. So we know all these sides. So how do we know them? M2P, because M is the midpoint of the radius AP, so its length is R over 2. Now, if you see M2O, then this length is sum of the capital R and small r, correct? Because they are tangential. So we know this is R plus R, right? Rather, this is half of R. This is half of R by 2 plus R, correct? Because this radius is half of R. R is this. R is A to
Mm.
P. Now, those two radius and half of radius combined, how much is O to P? That is what we need to figure. Well, the capital R is from here to here. That is capital R. If I take away R, I get this length. Is that okay? R minus R. So I made a
Yeah.
drawing here again, which shows you clearly this particular triangle. The side lengths are MP is R by 2, M to O is R by 2 plus R, small r, and P to O is the difference between the two radii, capital R minus R. Now, in this particular triangle, we have to write in terms of theta. So I applied the cosine law. So as soon as you apply the cosine law, which is OM square is equal to MP square plus OP square minus 2 times
All right.
MPMO cos of the angle given to you, which is cos theta, and you rearrange this particular uh, formula, right? All the terms in this, then you land up with the answer, which is R over R is 3 minus cos theta over 1 minus cos theta. Okay,
Mhm.
so that is how you can actually derive an expression. Now, important point which I would like you to look into is that in this type of a diagram, how do we find length of each segment or any two parts, right? So
Yeah.
relating those radii is very important. Once you do that, then you know sine law or cosine law, they can be applied, and then you may get a result which is something like this. Get an idea, right?
Oh, okay. Yeah.
Another interesting thing which you will notice here is that if I put theta equals to 90 degrees, in that case cos theta is 0. So in that case the
Yeah.
ratio will be 3. So in that case, the ratio of R over R is equals to 3. So that becomes a very
Really.
special case. If this theta would have been 90, that means this was a straight vertical line in this case, correct? In that case,
Mhm.
the ratio of capital R to small r would be 3, right? So,
Oh, okay.
so that could be a very special case to discuss. Now, here is the last question where I'll introduce you to bearing angle. You remember bearing angles?
Yeah, where it goes,
From
is it where
north,
you have north and then you go
clockwise from north.
clockwise? Yeah.
Correct. So just have a good look at it. Can you please read this question?
ABC is a triangular piece of land. C is 120 meters due west of A. Bearing of B is 289 degrees and 307 degrees from A and C, respectively.
Okay,
Calculate the area of the triangle ABC.
right. So we are given two bearing angles. Bearing of B has been given from point A as 289 and from point C as 307. Just to remind, bearing angle means from north going clockwise, right? So that becomes the angle. So clearly, we do have a triangle which we can solve using sine law or cosine law. So let's look into this condition. So here we know the two bearing angles. That means we can always find the angles inside, right? So the technique is to find those angles. That is kind of important. So first, if you look at angle A, in that case, we know this bearing angle is 289. So you can see how much it is. So 289 minus 270, which is this much of angle, gives you the remaining angle. So this particular angle here is 19 degrees. So we found the angle which this triangle makes at A. We know the length. The C is 120 meters to the west of it. So we know that is 120. Now the other angle, which is 307. So you can see that 307 can be calculated by, you could do, because this is the angle which we want, right? We want 90 plus that angle. Do you see that? 90 plus this angle. This is what we want. So what I've done here is first found what is this small angle. So this small angle is 307 minus 270. And then I have taken away from 180 to find this angle which is at C. So angle at C.
Wait, sorry. Where did 270 come from?
Okay, so when you have this kind of a shape, then the angle 270 is this. This is 190, this is 190, and this is 190. Do you see 270?
Mm-hmm.
From here to here, it is 270 degrees.
But then why at A does it say 289? Where is that from? Where to where?
Okay,
Just
let's look into this part again. This part. So A is like this, correct? So 289 is this much. So
to find that part, you
89,
subtract.
yes, I take away
Right.
270. So yeah, normally 270 is not the angle which people subtract. Somehow I see that as three right angles. Very easy to work with. Do you see that part?
Yeah.
So
Yeah,
we
definitely.
can easily find the small angle, taking away 270 from 289.
Because I was going to go on this crazy like 360 and then like do all of this problem, but that one's way easier to do.
Correct.
Yeah.
Yeah. Normally people go one full circle, take away, and do. But somehow I find 270 to be very useful to do in such questions, right? So in both the
All right.
questions, I've used this 270, but I have used your approach of 360 to find the other angle, which is angle BCA. So BCA, which is this big angle which I'm trying to find. So I'm saying it is 90 plus. So this is 90. Do you see this 90? 90 plus that angle. So that angle I'm working with 360 and the bearing angle given to me. So 360 minus the bearing angle is that small angle. So 90 plus that small angle is 143, which I get for the angle at C. You get the idea?
Yeah.
Once I find the two angles, I can find the third angle by 180 minus the sum of these two. And once you have a combination of angle and a side, you can always do sine law. So I've applied the sine law to find the side BC. So once you know two sides and included angle, you can apply the formula half AB sine C, right? So we applied the area formula half AB sine C to find the area of this land in this particular example. Is that
All right. Yeah. Clear. It's clear.
so that is how we have done this particular question, right? So I hope that helps. With this, we'll kind of end this video. So we have done all these types of questions. We included bearing angle, just to give you the variety of questions which could come based on geometry and trigonometry, right?
Right. Yeah.
Right. So we'll have our next class on Wednesday. I'd like you to prepare, and whatever is left and whatever you think we should be discussing, we'll discuss that after a day, right? I hope
All right. Okay.
that will prepare you for the test. So how was this learning experience? Did you really learn something from today's lesson?
Yes, definitely. So I learned about like how, again, this has come up many times, but like a combination of strategies, like we saw when you don't just use the cosine law, you use a mixture of cosine, sine, and yeah, so the combination, don't just think it's just going to be like one rule and that's it. And then like we saw with this one, like you said, if we can't use a calculator, then knowing your special triangles and
Yes.
like what is it, cos of 90 or whatever it is, like sub it in, because if you don't know those values, then you can't really work it out. So you just got to know that. And then circle theorems again, referring back to all those theorems, and one of the main ones that we did come up in GCSE, they said was quite tricky, was the alternate segment theorem.
Yes.
And like you discussed today, I saw how it can be like formed in like different ways, because I usually see the normal one, which is just upright, the two like this, but because you showed in a different angle, I could still see it was that theorem, but it was just in a different perspective. So yeah, that was interesting to see. And then the bearings, again, finding the angle inside the triangle. The thing is with bearings, I never actually done questions like that where you find the angle of the triangle inside. So that was actually really new to me, because most bearing questions I did at GCSE was just kind of when some boat is going and then you draw like make a triangle. I never find the angle inside the triangle. And then with the 270 method, I found that really helpful,
Yes.
because
It is
going
good.
the 360 way is really tricky. If I see it as like three different right angle triangles, that's really
Yes.
clear. So yeah, I learned so many tips.
That's
So
good.
thank you, sir.
Yeah, and good reminder. Wednesday, I'll actually teach you a few techniques how to use special triangles and how to solve many questions very quickly using some techniques. I'll take up that 15, 20 minutes lesson in addition to whatever
Okay, yeah.
topics we pick based on the special triangles, right? That should be good.
All
So
right, okay.
keep practicing. I will suggest that, at least from last 5 years, test papers, go through
Mhm.
the solutions. Once you go through their solutions, you get some brilliant ideas, and that should help you in day after
Okay.
tomorrow's challenge test. Okay?
Okay,
Okay.
hopefully. Thank you so much, sir.
My pleasure.
Have a
All the
good
best.
rest of your day.
Same
Thank
to you.
you.
Thank you. Bye.
Bye.